In this lesson, I'll show you how to find the area between two curves using integrals. This is part 4. Sometimes the given curves may cross in several places, or the limits may be specified in such a way as to define more than one region. In such cases, we find the area of each region separately. However, in a region where the curve that we designated as the upper lies below the other curve, the area of that region will be negative. We then add the absolute values of the area of each region. Here's an example that illustrates what we just discussed. Find the area bounded by the curve y is equal to x squared minus 4 and the x-axis between x is equal to 1 and x is equal to 3. What we have to do to find the area of these two together is find the area of each individually, then get their absolute values and add them together. Let's start by finding the area of A1. A1 is equal to, and according to this illustration, A1 spans from 1 to 2. So our integral will have a lower bound of 1 and an upper bound of 2. And the function still remains the way it is. So we have x squared minus 4 dx. We'll now find the integral of this function. X to the power of 2 becomes x to the power of 3 over 3. And this minus 4 becomes negative 4x. And we'll evaluate this at 2 and 1. Let's go ahead and do that. 2 to the power of 3 is 8 over 3. And minus 8. Once again, we subtract. Now this function at 1 to the power of 3 is 1 over 3, that's a third, minus 4. So whatever the area is here, we'll take the absolute of that, and that will represent A1. Let's use our calculator. Bracket 8 over 3 minus 8 minus, this minus right here, a third minus 4. As expected, the area is negative, but I'll take the absolute of negative 5 over 3, which is equal to 5 over 3. Now that I found the area of A1, I'll do the exact same thing for A2. I already know the integral, so all I have to do is set it up and evaluate. A2 between 2 and 3, x squared minus 4 dx. That was the integral. X to the power of 3 over 3 minus 4x. And we'll evaluate this at 3 and 2. Using our calculator, let's find out what that is. So we'll start off by inserting 3 into these two x's. 4 times 3 is 12. I just found out what that is at 3. Minus, now I have to find out what this is at 2. We have 8 over 3. I'm just looking at this part. Minus 8. I'll put brackets around this expression. This gives me 7 over 3. Like I mentioned earlier, I'll now add this and this together, where we get plus 5 over 3, and the area for this is equal to 4 units squared. Moving on to question 2, we're expected to find the area bounded by the curve y is equal to 1 over x and the x-axis for the following 3, a, b, and c. Let's start by finding the integral of this function. The integral of 1 over x is actually ln absolute of x plus c. So for part A, I will evaluate ln absolute of x at x is equal to 4 and x is equal to 1. According to the visual here, it is defined between 1 and 4. So evaluating this, ln at absolute of 4 minus ln at 1. If you input this into your calculator, you should end up with 1.386 units squared. So that's for part A. For part B, that's impossible. They want us to integrate between negative 1 and 4. Now there's a discontinuity here. Okay, so you can't integrate whatever this bound is defined by negative 1 through positive 4. It's impossible. And finally, for part C, we have to find out what happens to ln absolute of x between negative 4 and negative 1. Notice that this is below the x-axis, so expect your area to be negative. ln at 1. I'm not going to bother putting -1 because we have to take the absolute of -1, and that's +1. Minus ln at 4 gives me -1.38. Area here is -1.38 as expected. And there you have it. 2 more examples on how to find the area between two curves using integrals.